Introduction to Fractals. Discovery of a new geometry that describes the boundless universe we live in, one that is in constant motion, not as static images in textbooks. As Benoit Mandelbrot quote, clouds are not spheres, mountains are not cones, coastlines are not circles, and bark is not smooth, nor does lightning travel in a straight line. So we need an extra mathematical object, and that is actually fractals. These are examples of fractals in nature. What is a fractal? A fractal is a mathematical object that is both self-similar and chaotic. Self-similar means when you magnify an object over and over, you can get the same image. Chaotic means infinitely complex pattern. So, fractals are beautiful objects. They can generate by relatively simple mathematical process. The name fractals is derived from the fact that fractals don't have a whole number dimension. They have a fractional dimension. Fractal dimension. Everyone knows the dimension of a line is 1, square is 2 and cube is 3. And we can measure the distance, area and volume of those objects also. But what about the dimension of inside of a kidney or a brain? How can we measure the surface area? And what about a piece of broccoli or cauliflower? This is where fractal dimension can help us out. Fractal dimension allows us to measure the complexity of an object. How is the value of the fractal dimension calculated? There are different methods. One method is box counting method. It counts number of occupied boxes, then plot logarithm of occupied boxes versus logarithm of 1 by boxes per side. And its slope gives fractal dimension. And its geometric formula is logarithm of self-similar pieces divided by logarithm of magnification. How are fractals generated? Most fractals are generated by some sort of equation known as IFS or iterated function system. The output of this equation is then fed into itself again. This feedback is repeated over and over until the desired number of iteration passes or until the behavior of the value is determined. Depending on what sort of fractals you are dealing with, the criteria for stopping are also different. These are examples of fractal generated by IFS. Some different types of fractals. There are various systems for generating different types of fractals. One of the classic examples is Mandelbrot. Mandelbrot family of fractals is generated by using the quadratic function known as z square plus c, where both z and c are complex numbers. This is an example of Mandelbrot fractal. That's all about. Thank you.